Dear students, parents, and all teachers, welcome to our AdarshVidya educational YouTube channel. Today we will learn exercises of Class 8, Subject, General Science, Chapter 3rd, Force and Pressure. So, let's start. Can you recall? What is a force? Answer: force is a physical quantity that changes the state of rest or uniform motion of a body in a straight line. Use your brain power. First one. Make a list of some more examples in which contact and non-contact forces are applied. Write the types of force. Answer some examples in which contact forces are applied. First. To cut an apple with a knife. Muscular force, frictional force. Second. To lift a ball lying on the ground. Muscular force, frictional force. Next one. Some examples in which non-contact forces are applied. First. The motion of an earth around the sun, gravitational force. Second. The motion of an electron around the nucleus of an atom. Mainly the electric force. Next one. You have learned about static electricity in the previous standard. Electrostatic force is a non-contact force. To verify this, which experiment will you perform? Answer: do not switch on the fan in the room. Keep very small pieces of paper on the table. Rub the plastic comb against hair and bring it near the bits of paper. You will find that the bits of paper are attracted by the comb. The comb, on rubbing, acquires electrostatic charge. It induces opposite charges on the bits of paper. Hence, the bits of paper are attracted by the comb. Next one. It is easy to cut vegetables, fruits with a sharp knife. A blunt knife does not work here. Why does this happen? Answer: the effect of a given force varies inversely as the area of the surface on which the force is applied. The less the surface area, the greater is the effect of the force. The cutting edge of a sharp knife has less cross-sectional area relative to that of a blunt knife. Hence, it is easy to cut vegetables, fruits, with a sharp knife rather than with a blunt knife. For a given force, pressure is inversely proportional to the area of the surface on which the force acts. Next one. You must have seen a vegetable vendor carrying a basket on her head. She keeps a twisted piece of cloth on the head, below the basket. How does it help? Answer: keeping a twisted piece of cloth on the head increases the area of the surface on which the weight of the basket containing vegetables acts. Hence, the pressure produced by the force, weight, is reduced and it becomes easier to carry the basket. Next one. We cannot stand at one place for a long time. How then can we sleep on a place for 8 and odd hours? Answer: when we stand, our weight acts on relatively small surface area, resulting in increased tension on the muscles of our legs. Hence, we cannot stand at one place for a long time. When we sleep, our weight acts on relatively large surface area, resulting in comparatively reduced tension. Therefore, we can sleep on a place for 8 and odd hours. Next one. For skiing on ice, why are long flat skis used? Answer: the pressure produced by a given force depends on the area of the surface on which the force acts. The greater the surface area, the less is the pressure produced. The skis used to slide over snow are long and flat so that the area is increased and hence the pressure is decreased. This makes it easier to slide over snow. Next one. At the sea level, the atmospheric pressure 101 x 10 cube Pa is acting on a tabletop of size 1 square meters. Under such a heavy pressure, why doesn't the tabletop crumble down? Answer: the air below the tabletop exerts pressure 101 x 10 cube on it in the upward direction. Hence, the tabletop doesn't crumble down. Next one. While pulling a bucket from a well, the bucket full of water immersed fully in water appears to weigh less than when it has been pulled out of water. Why? Answer: when a bucket full of water is immersed in water, the net force acting on the bucket equals weight of the bucket full of water. The buoyant force exerted by the water on the bucket. The buoyant force due to a fluid is proportional to the density of the fluid. The density of water is much greater than that of air. Therefore, the buoyant force acting on a bucket full of water while it is in water is much greater than that when it is out of water, that is, in air. Hence, it appears to weigh less while it is in water than when it has been pulled out of water. Next one. Take a piece of thin aluminium sheet and dip it in water in a bucket. What do you observe? Answer: it sinks in the water. Next is, now shape the same piece of aluminium into a small boat and place it on the surface of water. It floats, isn't it? Answer: yes, the boat floats on the surface of water. Next one. Explain the observations in the earlier experiments according to the Archimedes principle. Answer: the increase in the length of the rubber band, Y, is proportional to the downward force, F, acting on it. 1. When the stone tied to the rubber band is hanging in air, the magnitude of the buoyant force exerted by air on the stone is negligible compared to that of the weight of the stone. Hence, ignoring it, we have F equals Fg equals mg, where m is the mass of the stone and g is the acceleration due to gravity. 2. When the stone is immersed partially in water, F equals FgFb, where Fb is the magnitude of the buoyant force exerted by water on the stone. Now, Fg equals Vpg and Fb equals xVpWg, where V equals volume of the stone, P equals density of the stone, 15 equals volume of the water displaced by the part of the stone immersed in water equals volume of the part of the stone immersed in water, x less than 1, and P equals density of water. Therefore, F equals Vpg xVpWg equals Vpg 1 xPW slash P. Fg 1 xPW slash P. This shows that as the stone is gradually lowered in water, x goes on increasing and hence F goes on decreasing. Therefore, elongation, y, of the rubber band goes on decreasing, that is, the length of the rubber band goes of decreasing. 3. When the stone is completely immersed in water, x becomes maximum equal to 1. Here, F equals Fg 1 pW slash P. This is the minimum value of F. Here, the elongation of the rubber band is minimum, i.e., the length of the rubber band is minimum. Exercises. Questions and answers. Question. 1. Write proper word in the blank space. The SI unit of force is dyne, Newton, joule. Answer. The SI unit of force is Newton. C. The air pressure on our body is equal to pressure. Atmospheric, sea bottom, space. Answer. The air pressure on our body is equal to atmospheric pressure. C. For a given object, the buoyant force in liquids of different is the same density, different area. Answer. For a given object, the buoyant force in liquids of different density is the same. D. The SI unit of pressure is Newton per meter cube, Newton per square meter. Kilogram per meter square, Pascal per meter square. Answer: the SI unit of pressure is Newton per square meter. Question 2. Make a match. A group with B group. Answer: 1. Fluid, same pressure in all directions. 2. Blunt knife, lower pressure. 3. Sharp needle, higher pressure. 4. Relative density, specific gravity. 5. Hectopascal atmospheric pressure. Next is question 3. Answer the following questions in brief. First, a plastic cube is released in water. Will it sink or come to the surface of water? Answer: it will come to the surface of water. This is because its density is less than that of water. Next is B. Why do the load-carrying heavy vehicles have large number of wheels? Answer: the pressure produced by a give force depends on the area of the surface of which the force acts. The greater the surface area, the less the pressure produced. Load-carrying heavy vehicles have large number of wheels so that the load, weight, force is distributed over large surface area of the wheels in contact with road. Hence, the pressure decreases and the tires do not burst. Next one. C. How much pressure do we carry on our heads? Why don't we feel it? Answer: the air pressure at the sea level is about 101 by 103 pascals. This is the pressure that we carry on our heads. The cavities in our body are filled with air, and arteries and veins are filled with blood. Their pressure balances the pressure due to the atmosphere. Hence, we don't feel the atmospheric pressure. After that, question 4. Why does it happen? First, A ship dips to a larger depth in fresh water as compared to marine water. Answer: the buoyant force action on the body is proportional to the density of the fluid in which the body is immersed. The density of fresh water is less than that of marine water. Hence, the buoyant force on a body in fresh water is less than that in marine water. Therefore, a ship dips to a larger depth in fresh water as compared to marine water. Next one. B. Fruits can easily be cut with a sharp knife. Answer: the effect of a given force varies inversely as the area of the surface on which the force is applied. The less the surface area, the greater is the effect of the force. The cutting edge of a sharp knife has less cross-sectional area relative to that of a blunt knife. Hence, it is easy to cut vegetables, fruits, with a sharp knife rather than with a blunt knife. For a given force, pressure is inversely proportional to the area of the surface on which the force acts. After that, C. The wall of a dam is broad at its base. Answer: the pressure at a point in a liquid is proportional to the height of the liquid column above it. Hence, the pressure of water in a dam is much greater at the bottom of the dam than at the top. B. To withstand this high pressure, the wall of the dam is made stronger and thicker, broad, at the base than at the top. Then, another is D. If a stationary bus suddenly speeds up, passengers are thrown in the backward direction. Answer: when the passengers sit or stand in the stationary bus, they are in a state of rest. When the bus suddenly speeds up, the lower part of their body in contact with the bus acquire the speed of the bus. The upper part of their body, however, continue to be in the state of rest due to inertia. Hence, they are thrown in the backward direction. Next question is Question 5. Complete the following tables. Answer, using the formula, density equals mass upon volume. When mass 350 kg, volume 175 meter cube, then density is 2 kg per meter cube. When volume 190 meter cube and density for kg per meter cube, then mass is 760 kilograms. In next table, using formula, relative density equals density of a metal upon density of water. When density of water 10 cube and relative density is 5, then density of metal is 5 into 10 cube. When density of metal is 8.5 into 10 cube, and density of water is 10 cube, then relative density is 8.5. In third table, using formula, pressure equals weight/area. When area is 0.04 meter square and pressure is 20,000 Newton per meter square, then weight is 800 Newton. When weight 1500 Newton and area is 500 meter square, then pressure is 3 Newton per square meter. Next question is question 6. The density of a metal is 10.8 into 10 cube kg per meter cube. Find the relative density of the metal. Solution, given density of the metal equals 10.8 into 10 cube. Density of water equals 10 cube. Relative density equals, find it. Formula is relative density equals density of the substance upon density of water. Relative density is equal to 10.8 times 10 cube upon 10 cube. Relative density equals 10.8 then. The relative density of the metal equals 10.8. Next is question 7. Volume of an object is 20 centimeter cube and the mass in 50 gram. Density of water is 1 gcm free. Will the object float on water or sink in water? Solution, given volume of object equals 20 centimeter cube. Mass is equals 50 g. Density of water equals 1 gcm free. Density, P equals mass upon volume. Density, P equals 50 upon 20 is equal to 2.5 gcm free. It is greater than the density of water. Hence, the object will sink in the water. Next one. Question 8. The volume of a plastic-covered sealed box is 350 centimeter cube and the box has a mass 500 gram. Will the box float on water or sink in water? What will be the mass of water displaced by the box? Solution. Given volume of box equals 350 centimeter cube. Mass of box equals 500 gram. Density of box equals, calculated. Density, P equals mass upon volume. Density, P equals 500 upon 350 is equal to 10 upon 7 gram per centimeter cube. It is greater than that of water. Hence, the box will sink in water. The volume of water displaced by the box, V, equals the volume of the box equals 350 centimeter cube. Now, density, P equals mass, M, upon volume, V. Therefore, M equals PV. The mass of water displaced by the box equals 1 gram per centimeter cube into 350 centimeter cube equals 350 gram. Dear subscriber, if you have any problem in this video, chapter, or lesson, please comment it. Please like, share and subscribe our AdarshVidya educational YouTube channel. Thanks for watching.